Welcome. My name is Amol Mathur. I'm the SVP of products for Prisma Cloud. I've been doing cybersecurity for a bit. Before Palo Alto, I worked at Trellix, Akamai, ran AppSec, network security, enterprise, etc. That's all I've done in my career, so I find it quite interesting. Now, sort of before I go into the topic, which is, how do you secure applications by shifting left and shielding right? Let me talk a little bit about, quick Palo Alto Networks. What do we do? What are we focused on, and so on, right? So there are three sort of grand challenges, three key missions that Palo Alto is tackling. Number one, we are transforming network security to deliver best-in-class security, whether it's hardware firewalls, virtual managed services, or market-leading SASE. The second is, how do we completely transform security operations with a fully integrated approach with data, analytics, automation. And the third one, which is what we're going to focus on today, is how do we secure applications from code all the way to public cloud. Now, the third thing that you see at the bottom is Unit 42, which is the underpinnings of everything that we do and develop. Essentially, a world-class threat research, threat intelligence, and security response team, which provides us a lot of real-world, hands-on intelligence on what's going out in the threat landscape. So let's sort of zero in on the code-to-cloud journey or mission that we are focused on. Now, before we sort of go into how are we thinking about it and what are we tackling, I just wanted to level set on what are the modern challenges of using today's cloud, developing, deploying, running applications today in the cloud, right? So what we see is there's like a perfect storm of innovation and risk, right? On the innovation side, we see that applications are no longer just natively 100% developed. They're kind of like assembled together using a bunch of first-party and third-party pieces. In fact, 75% of code out there, based on all sorts of different studies, uses open source components, which you might have no control over as an organization. Now, on the risk side, 80% of all open source components have more than one vulnerability. And we all know that as soon as a new CVE comes out, and it's exploitable, within 15 minutes, you start seeing people on the internet trying to find systems that are vulnerable and attack. I'm sure all of you lived through the joyous horror of Log4j, which was, I think, right around this time in the holiday season running through Christmas, where it was just, extremely hard. Now, on the continuous delivery side, like applications used to be monolithic, maybe one release a quarter. Now we see 77% of organizations are releasing software weekly. And there are a large number of organizations, especially born in the cloud, internet-facing apps, which are doing a number of changes on a daily basis, right? So the speed of what you're putting out there is increasing, but the amount of security personnel that you have to deal with securing and analyzing is not growing. So some studies say there's a 10-to-1 ratio of developers to security. I think that ratio is far more skewed, and I'm sure based on your own personal experience, you just don't have nearly as many people trying to secure your application, your infrastructure, and so on. And the last one is Gen AI, right? I mean, anybody heard of Gen AI? Right? You can't walk 5 feet in a conference like this and not hear about Gen AI, or go online and not hear about Gen AI, right? So what we are seeing is that Gen AI is causing a lot of acceleration in security risk. So on one end, we see that the output of software that can be produced with Gen AI, with things like copilots and so on, is going to increase the velocity by 10x. But when you evaluate the software that Gen AI is producing, and there was a study published, 40% of the 1,600 plus things produced by the GitHub Copilot had a lot of vulnerabilities. Even on the attack side, you can see attacks scaling in speed, in stealthiness, because Gen AI can craft these attacks much, much faster. So it's a perfect storm between all the innovation that public cloud and all these new technologies afford, but it brings with it a lot of substantial risk as well. Now, let's talk about how cloud applications are assembled today, right? They're assembled in different stages. So everything starts with code. You've got custom code. You've got open source code. You've got codified infrastructure or IAC. This sort of creates a bunch of infrastructure, and then those instances get deployed in your runtime applications. So what starts with probably a single issue in a single package all the way in the left can become hundreds or thousands of deployed vulnerabilities on the right, right? Whether it's open source packages causing vulnerabilities, whether it's ISC resources, a single resource used in 1,000 places causing the same misconfiguration. Now, the way the industry has responded, and largely how people have tried to secure all those sort of exclamation marks, which is nothing but the attack surface, is use point products, right? There's an alphabet soup of security posture management, and you can put whatever letter you want at the beginning, right? Everything from cloud to application to data to identity to whatever, right? Now, what has happened is that while these solutions are trying to protect their little piece of the puzzle, there is no intelligence that is shared between these solutions, right? There is no context being shared from runtime back to the source or from source to the runtime. And this causes a lot of operational efficiencies, because if you look at your own organizations, for vast majority of the organizations, there's an AppSec engineer, which is very different from the DevOps people managing infrastructure, which is very different from the SOC that is looking at the runtime incidents and alerts that are coming from technologies that are able to detect and prevent threats. And the tool that becomes the most collaboration tool across all these is Microsoft Excel, essentially, a countless number of meetings in Excel. And this is causing a lot of risks to go unaddressed. So even in this day and age, when you're investing in all sorts of security posture management solutions, it's just not enough. So let's look at some of the stuff that we are seeing in terms of risk that is going unaddressed. So we did an assessment, from our own customer base, 1,000 plus customers, 210,000 plus cloud environments, 70,000 repositories. And what we saw is, like, for example, 83% of the customers still have hard-coded credentials in their SCM systems, or 75% customers who have not even enforced basic AWS CloudTrail logging. And as a result, you see that it takes a ridiculous amount of time, 145 hours, for an alert to even get resolved, even if it is a critical alert. And customers are taking a significant amount of time because they just do not have that context, that intelligence stitched from all these point solutions. Now let's talk about open source, right? Everybody uses open source. I saw this line. I don't know where it came from. I just stole it. It basically says, hey, the magic of open source is anyone can use it, but no one is obligated to maintain or secure open source, right? So we looked at about 70,000 repositories that we monitor, which were using a little over 100 open source packages, and 63% had unpatched critical or high vulnerabilities. Now, if you think about it, right, like these are like an abundance of open source packages out there. These are being put into production applications with a high degree of vulnerabilities. The other side of open source that we are seeing is that open source packages are being weaponized and targeted to create supply chain attacks. SolarWinds, CodeCov, all of these have been in the public domain, where these packages, which are very often used by developers, are essentially being weaponized to cause applications to have major breaches. So as a result, all these fragmented solutions out there, you still have issues where large organizations with significant investments still have had major breaches, right? I mean, you've heard of Circle CI. It got in from a developer laptop using a malware and then reused a token, or SolarWinds, which was a very famous breach out there, and so on. So with all this sort of threat landscape and all this investment, what is the right approach? How do you provide that intelligence so that you can actually have a reasonable shot at protecting your applications? So we sort of spent, over a year, or the last year, really thinking about how do we take what we have in terms of best-of-breed capability and really stitch it together to allow for customers to have and end users to have a reasonable chance to securing their applications. So a few things that we have thought about. Number one is you've got to be empowered to fix at scale the issues at the source, right? As we saw, one issue at source becomes more than 1,000 issues in runtime. If you're just trying to fix stuff in runtime and not fixing the root source, you'll always be in this endless loop. Number two is you've got to block the breaches in runtime. So while you're fixing, you've got to have a way to look at events, look at actual incidents happening, and have preventative inline technology to block it. So we came up with a code-to-cloud sort of intelligence that stitches together from your source, your infrastructure, all the way to your runtime environment. And I'm going to walk through capability that we always had and some new innovation that we have recently launched at tackling some of these problems where this context is just not available. So let's talk about visibility first, right? Now, we have always had the ability to look at 350 plus cloud services, really understand what are the misconfigurations in these services and so on. So this is table stakes. This has already been there. What we have added on top is how do you understand and visualize your rogue shadow IT or shadow clouds, right? So we have a capability called Cloud Discovery Exposure Management, which is an outside-in view into your unmanaged, unsecured cloud assets. These could be assets in the cloud that you already know about, or these could be just clouds which you don't even know about, which are unsanctioned and just being used by teams to deploy applications. So not only it discovers all your assets, but it also discovers the vulnerabilities, the risks that are exposed as an outside-in view from the internet. Now, once you know all your known and your unknown assets with shadow clouds, then you need to sort of figure out, okay, what are the risks, right? Whether it's vulnerabilities, misconfigurations, overly permissive or misconfigured identities, or IAM roles, or data that is exposed or being moved. So we have about 1,500 plus different checks. You can tailor it to however you want to alert. And then on the incident side, we are looking at user anomalies, network anomalies, how malware is moving in your environment, and so on and so forth. Now, of course, we have a ton of out-of-the-box policies, but you can write your own custom policies as well. And then the last area is compliance. Who doesn't love compliance, right? I mean, compliance makes pockets open. Compliance also gives people sleepless nights. But it's just the tax that we all have to pay. And we are trying to make that as easy as possible by giving you one-click ability to take your posture or your good things or your gaps and map it to all the widely known compliance standards, whether you're financial services or healthcare or some other industry. Now, the thing that we have recently added into the visibility is a capability called App DNA, right? So today, when you think about an application, it constitutes of your compute resources, network resources in the cloud. You got some storage. You got some data assets, APIs. But at the end of the day, all of these things group together in the service of some business application. So let's say if you're in the retail industry, you could have a payment application, a shopping cart application, a product catalog application. And typically, what we hear from end users is that they want to visualize risk, report risk, on how the applications are constructed versus on container images or repos or running virtual machines and so on. So using Kubernetes namespaces or if you have a mature tagging strategy, we automatically, without any end user config needed, discover the application boundary across all these resources. Now, there are sort of two ways to think about this. One is we create your application inventory so you can go, once you onboard your cloud account, look at, hey, these are all my apps. But also this becomes rich context that we overlay throughout all the risks that we visualize, which I'll talk about in the subsequent slides. So, once you have sort of gotten the visibility, you've gotten an understanding of what your applications are and all the infrastructure or resources that support that application, now it's time to really prioritize and understand your risks, right? Now, everybody talks about, hey, I want to prioritize my risks so that I'm focused on the most important things. But it's table stakes. It's very important, don't get me wrong. But what's really, really important at the end of the day is how are you successfully set up to remediate or mitigate those risks, right? Prioritization just basically reorders the same 1,000 plus things or more in a different order, but you still need to go do something about it. You still need to find the people who will action those issues and so on. So the way we have sort of dealt with this is that we get signals from multiple different sensors, you can call it, whether it's looking at vulnerabilities or misconfigurations in code, or whether it's looking at container images or your running instances, your identity permissions. We put all of that together in a single data lake. And then we are able to correlate risks and attack paths. So for example, you could have 5 or 6 disparate events, which are interesting, there are issues, but when stitched together, they are actually a latent risk, which at any moment can become into a breach. So for example, you could have an EC2 instance that's exposed to the internet, has a critical vulnerability, a misconfiguration, and an IAM role which is overly permissive with access to an S3 bucket with sensitive data inside it. Now, these are like 6 different atomic things, but when stitched together, they present a major risk to your organization. So the whole idea is that you might have, a billion log lines, 17,000 total alerts, within that critical alerts, but what really matters, what you really need to action on is those 20, 30, 40 things which we call attack paths, which we are automatically able to stitch together in our platform. Now, the next thing is, once we stitch these things together, you need to sort of understand what is the root cause of this. You need to get all the context around it, right? So we are able to sort of overlay this in a graphical format and give you sort of metadata and details for every portion of that atomic incident. So whether it's understanding what that workload is, what issues that workload has, or what sensitive data is in the storage bucket, you're able to sort of get that context with a single click. Now, I talked about app DNA in a few slides back. When you have an incident, we also overlay what is the application context of the resources which are impacted as part of that incident. So whether it's a container image or whether it's a storage bucket, like what applications or microservices are these supporting? We automatically discover that, which also helps you identify the owner that can actually go fix that problem, or the owner of that particular asset that needs to be looped in. Like one of the things we hear from end users all the time, establishing that ownership for problems and assets becomes a major challenge. And then so you know a lot of these issues, but how do you go remediate these issues? That's a major challenge, but we provide that sort of right there in the way when you visualize these risks. Now, for folks in the room who are in DevOps, who are getting bombarded by security, or if you're in security and giving issues to people who actually go remediate, one of the biggest points of friction is they just give you the information and provide you no context on how to go fix it, right? And that becomes a major challenge. Like, where is this issue? How do I go fix it? Why is it important? All of that issues, including detailed recommendation steps, is what you need to be able to be successful in your remediation. Now, I talked about the fact that remediation is far more important. You need to demand that your solutions need to enable you to do remediation and not just prioritization. So we have approached this in 2 different ways, right, from a remediation standpoint. You can either fix a particular issue in the cloud, or you can fix it in code. So let's talk about the cloud aspect first, right? So let's say you have a misconfiguration. We have provided automation where you can say, all right, you know what? Either I want to go click the button called Fix in Cloud, or I just want to set a policy where if a certain type of issue is found, just automatically go remediate that issue, right? Like, why make me come into the console and analyze? Like, I already know that this is an issue. I already know you can fix it. I've given you the, the delegated permission. Just go ahead and fix it for me, right? So it helps you build remediation. It helps reduce your mean time to remediate, which is a key metric that I know everyone is focused on. And then if you don't want to do auto remediation and just send it to the right folks, then it gives you all the context that eventually the DevOps teams need to go remediate these issues. The next way we think about remediation is fix in cloud, right? So let's say if you have a known vulnerability on an internet exposed asset, right? What if you could automatically say that, hey, if a critical vulnerability is found on an internet exposed asset, I automatically want a pull request assigned to the right developer, because I can trace that issue from runtime back to exactly where it came from, in which package, from which repo, or which ISE file, and I want that issue automatically assigned to them so they can review it, they can merge it, and they can remediate, right? Now, if you don't have this automation built in, you're essentially downloading CSVs, throwing it over to your DevOps team, and then they're like, what the hell do I do with this? This becomes a mounting challenge. So solutions that help you provide that right context and just automate this process is what is really going to help you have a better handle on your risk. Now, another issue that we have tackled, and this is a thing we released recently, is around vulnerability management, right? Like vulnerability management as a space maybe is not as cutting edge, but it's still something that we have to deal with every single day. And the biggest challenge is there's just too many vulnerabilities. Like, how do I go remediate all these vulnerabilities? It's not even possible. A lot of these vulnerabilities don't even have patches available, so what do I do with it, right? So we created two things. Number one is we created a way to hyper-prioritize, and not just prioritize based on critical risk or a standard CVSS score, but really prioritize based on what could turn into a breach at this moment. Right? So we take in all the vulnerabilities, whether it's coming from your registry images or runtime, or it's coming from SCA scans in your source code. We can say, all right, you've got all these critical and highs. Within that, a subset of these are actually exploitable. A subset of those are actually patchable. And within the patchable ones, even though that could be a large number, these are the ones actually impacting packages which are in use in runtime. Which means this is, shit could go wrong now. You need to go fix that now, right? So that's the level of hyper-prioritization. Now, the next thing, and if all of you remember the morning of Log4j, right? It sounds like morning after Christmas, but the morning of Log4j, everybody got this question, hey, are we vulnerable? Where is Log4j? Where all can I find Log4j, right? And I remember I was at Akamai at that time, and even we as an organization were struggling because everybody has information in all these disparate systems, and you have to merge all of this together. So we created a capability in which I'll show you a graph called the Unified Vulnerability Management, where you can search for any vulnerability, and it'll tell you exactly where that vulnerability exists in your code repositories, in your images, and your running instances in production. If you could get that visibility and that traceability from cloud all the way back to code, that could be super, super powerful. So we talked about sort of prioritizing and remediating a lot of the latent risks from misconfigs, vulnerabilities, attack paths, which are a combination of issues and so on. Now let's talk about actual stuff that has gone wrong or is going wrong, which is incidents in your environment. And how can you mitigate, right? So we sort of detect threats in sort of three large buckets. Number one is we run deep analytics, using behavioral modeling, user entity analysis, machine learning, even bringing in intelligence from our Unit 42 team, and we are looking at sort of your cloud configuration and your audit trails, your network and flow logs. We ingest 1 trillion flow logs on a daily basis, your web and API traffic, because we have a full-featured app and API security capability, and all the DNS logs. And we're trying to sort of stitch together the context to see, is there user behavior that we see that looks suspicious and anomalous, right? And does that indicate a specific pattern of something that has already happened or is happening at this point in time? So that's number one, that we constantly surface those threats and anomalies. Number two is when you have your actual application workloads, right? I mean, you have container images, which has a lot of third-party dependencies, which could have malware or crypto miners, or it could have vulnerabilities, zero-day or known vulnerabilities, which are being exploited. So we have agents, very lightweight agents, which are both host, container, and serverless aware, which can look at actual lateral movement, or if the malware is trying to break out of the container and attack the host, or if there is anomalous behavior of the container which has not been observed before, you can detect all those threats. And we use machine learning and anomaly detection. But the other thing which end users use a lot is our behavioral modeling, right? So you can say, all right, I've got this container. This is a known good image. This is how the container should behave, and you can make our system learn that good behavior and say that at a network level, at a process level, at an IP level, on where it's supposed to communicate, If it deviates from that baseline, if that baseline is so well established, then I want to take punitive action, or I want to get alerted on it, and so on, right? And you can manually go teach the system on what that expected behavior is. You can do allow listing and block listing, and so on. And then the last sort of set of capabilities is your layer 7 attacks, right? So I mean, you could have an application which has an API interface or an actual web interface on 443 that's exposed. How do you detect against the OWASP top 10, which is a bunch of port scanning, reconnaissance, injection vulnerabilities, or all the way to bots trying to attack your infrastructure? It could be credential abuse. It could be just bots which are scraping data from a product page or a pricing page. It could be just bots trying to do a denial of service attack, although I would say it's much better to deal with denial of service at the edge of the internet using a CDN versus doing it right next to the app. But we do have capability that can detect against DOS attacks. And then the last one is any kind of API abuse, right? We did a research paper on BOLA attacks, using AI to detect those. That was quite fascinating. But any kind of abuse against your APIs, which is abusing the actual behavior of the API, we can detect as well. So anything that a standard WAF solution can do. So in summary, sort of, you can investigate all your issues. You can look at all the context. You can get all the details and analytics. And then you can drive the response, whether it's fixing in code or fixing in cloud. The one thing that we are thinking about, and I know that deploying agents is not something that people do very lightly or typically automate in wartime, but what if we observe malicious activity on a workload and we can provide a way to automatically go deploy an agent, enable that behavioral profiling, and then give you a profile to now go block? That's something we haven't done yet automatically. It's still a process that you need to go through and deploy manually, but we are thinking about that as the next step in our fix in cloud journey. Okay, so you have the visibility, you have prioritized, you have either remediated or mitigated. The next thing is, you want to expand your investigative capabilities and try to understand what else could be going on in your environment based on what you have already seen and remediated or seen and mitigated. So we have a very powerful search and investigate capability where, both using our own query language or using natural language, you can ask it questions. And it will give you that answer and render it in a graphical format, right? So you can ask, hey, show me EC2 instances which are internet exposed, which have a specific CVSS score or higher vulnerability, and which has an overly permissive IAM role, or some combination of that. And it will render you all that information in a graphical format, so then you can investigate and understand exactly where that issue is, and also investigate the blast radius of that issue. That if someone exploits a particular EC2 instance, where else can they go? This is also the place in the screenshot, if you can see on what you see up there, is you can say, hey, where all do I have vulnerability X, right? CVE, blah, 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 right? What you see on the screen, essentially, it'll render back and say that particular CVE exists in these code repositories, in these container images in your environment, and in these runtime instances. So in a single shot, something that could take you days or weeks to find out because your systems are all disconnected and not sharing any context, you can do that with this code to cloud intelligence layer. Now today, we largely only support our first-party information, which means that you have to ingest, or you have to be using our IAC scanning and our SCA and our vulnerability scanning and our runtime and so on. On the vulnerability side, there are two partners that we do ingest data of, which is Qualys and Tenable, and we are looking at expanding in areas because we all realize that, look, as much as we want everyone to buy everything from Palo Alto, that doesn't happen. There are incumbent vendors deeply entrenched in different parts of the app lifecycle, and you want to leverage your existing investments. So we are constantly looking at how we can bring in third-party intelligence so that when you're asking these questions or trying to visualize risk or understand risk, it's stitching together not only data that we find, but also what we import from third parties as well. So that's a very powerful sort of, call it enterprise search and investigate capability across everything that we see, and you can ask it complex logic and so on. Okay. The fourth thing that we've been working on, and this is like super exciting, I just love this capability, is our AI Copilot, right? And you can go see a demo of it. I believe it's on our booth in the expo hall as well. And we are thinking about AI in general in sort of three buckets, right? In two categories and three buckets. So one is your precision AI, which has existed for a long time, machine learning, statistical models, circadian patterns, et cetera, and we have been using it and we continuously use it to give you better security outcomes, whether it's detecting threats, automatically detecting blast radius, et cetera. The second and third bucket is how do we use generative AI, which is relatively newer, to really give you a much better user experience, right? So there are two aspects we are focused on. Number one is how can the Copilot be sort of a sidekick, a very smart, intelligent sidekick to help you efficiently automate operations, give you answers to things you want to know about your environment, right? And the second set is, if you just want to know something about the product, today you would have to go to documentation, go find that use case, and then go read through it. But what if you could just ask a very simple question? Hey, how does Prisma Cloud integrate into ServiceNow? Rather than going and finding this six clicks deep into the documentation, if you could just ask that question and get a very specific response and a link to where you can find it in the documentation, wouldn't that be a powerful thing that makes your experience much better? So that's what we are focused on with our AI Copilot capability. So let me sort of show you and this is actually in production now. So AI Copilot, it manifests throughout the product. You can bring it up, doesn't matter where you are. But let's say you ask it a simple question, hey, am I vulnerable to Log4j? And you can ask the same question in multiple different ways. We are able to extract that simple language and extract the intent of the question. So you can say, do I have Log4j? Where all do I have Log4j? Is Log4j in my environment, et cetera, et cetera. So you ask that question. You instantly get information on where Log4j is running. So the same thing that you were looking in your search and investigate capability, or the same thing you can get from your vulnerability dashboard, you can just ask a very simple question, right? Like, one of the things that our CEO, Nikesh, has challenged us is like, look, he thinks in 5 years, a lot of companies will not have a fixed UI. You can just ask questions like you ask Google or Bard or Perplexity or any of those engines, and it'll dynamically generate the UI that you're after. And this is what it's sort of the early beginnings of that is, right? So you ask it a question, it tells you exactly where it's running. We have also included capabilities where you can say, just click on a button and say, hey, explain this graph to me. Or explain the risk, like what am I looking at? And it'll sort of explain that in simple English, so you can, even if you're not familiar with the product as much, you can really understand it. So, once you get the answer and the advice, then you can say, all right, I want you to go remediate all of this. Now, remediating all of it is not a nuclear option. It just means that, all right, I want you to go issue Jira tickets or ServiceNow tickets or automation or a pull request so that everybody who needs to go do something about it throughout the app lifecycle does something about it. And essentially, you could fix it right from the AI Copilot from code all the way to the cloud. So the fixing part and remediating part is still under development. That's why I have that asterisk there. But in terms of giving you that visibility on exactly where that vulnerability is in your environment across the life cycle, the AI Copilot can do it for you. The last thing I want to talk about is that obviously, you visualize risk, you prioritize, you remediate, and you go through that life cycle day in and day out. But it's very important to understand how you are doing as an organization, right? So, dashboards and graphs are nothing special. Every product has it. You can visualize trend lines over time. Is your risk going up or is your risk going down? You can do the same thing in the different phases of the app life cycle. But where we are taking this next is we have created a concept called collections, which means that you can report the same thing that you see at an aggregate level across different constructs. So, for example, what you see at the bottom of that screenshot, it says, hey, show me all the risks and how they are being burnt down through the app life cycle per application. So rather than you having to export it and then sort it and create this grouping to then report up and say, hey, these are the way application teams are doing or different business units are doing, you'll be able to do that natively out of the box. So this could become a celebration thing across teams, or this could become your wall of shame, depending on how you want to use it in your organization. But this gives you instant visibility on how you are doing through your app lifecycle with the risk and the different trends and incidents and attack paths and so on and so forth. So, in conclusion, like, I'm sure that you folks have either invested or you're looking at investing in different kinds of security posture management and runtime. And look, there are a lot of good products out there in the market. At the end of the day, what I would say is you've got to look at a strategy where your solutions are providing the intelligence to each other. They are providing the right context, because prioritization is not good enough anymore, right? You have to have solutions that put you on a path and enable you to do rapid remediation. Now, one of the other things I wanted to flash is that we have been sort of doing this for a little over 6 years now, and having done this for this long, it gives you a lot of sort of battle-tested feedback. So in terms of whether it's 1 trillion flow logs that we ingest every day and we run our models on, or 13 million plus containers that we protect today, and which gives us deep insight into the different malware, crypto miners, or vulnerability exploits that are happening, or whether it's 2 million plus IAM permissions that give us a lot of understanding. Like we've been around the block and done this for a while to know sort of what kind of solutions will really help you in reducing your risk and stopping breaches in the future. So with that, thank you very much. Please stop by the Palo Alto booth, booth 832, and you can see a demo of any of these capabilities as live production that I talked about. Thank you.